well. I'm Matt Roberts. I'm from Durham University. I do my work in both the Department of Archaeology and the Department of Computer Science. I started I have got a background in software engineering, a background in CS. However, machine learning, I only really started getting involved with it in the summer of 2017. And archaeology, I really only got started with that in October of 2017. So in both cases, I'm kind of coming to this from the perspective of a newcomer, trying to see how these two disciplines could be used to interact with each other. The primary research questions that I've been attempting to pursue was, number one, how well does a machine learning dataset created from a digital archive of a museum, library, or similar GLAM institution work with the utilization of machine learning? It started to expand a little bit when I started talking to folks in archaeology, and they started asking me, well, how also could we try and apply this in a real world context? What sort of problems that are currently facing cultural heritage could we apply this to? And thus I've started to also see whether or not it can be applied to issues currently facing modern day illicit trafficking of antiquities. The primary source of my dataset has been from the Durham University Oriental Museum. This is a really nice museum that has had a long association with the university itself. It came out of the School of Oriental Studies from the 1950s and has a very large of objects and antiquities coming from China, Japan, India, but also specifically from Egypt. And partly that's because they had a Duke of Northumberland who, back in the 1880s to 1900s, went over to Egypt and acquired a lot of material. After he died mysteriously in Paris, that material then was given over to Durham University and eventually found its way into the museum's archives. It was also supplemented by Sir Henry Wellcome, a pharmaceutical industrialist around the same time, collecting lots of material from all across Egypt, bringing it over to the UK, shoving it into various crates, putting them in warehouses. And then once again, when he passed away, that all got distributed to various museums across the British Isles, which included Durham. So I actually have a fairly good data set to be working with, primarily because of the efforts that the museum has been doing since about 2001. They've been digitizing their archives, and they've been following a very precise manner of approaching their records. They have file folders that are organized according to the provenance, so the various ways that this material entered into their archives, but also the way that they're tagging their files follows a very methodical scheme, as well as their digitation efforts for photography. They'll take a photo of the front, back, left, right, top, and bottom, and label all of those within the file name itself. They'll also take sort of semi-perspective shots of the objects if they feel it's warranted. That means you have lots of data of a single object that you can start that you can easily find within their computer system. It also has the accession number for it, and so it just gave me, as someone coming from outside of the museum itself, a very easy way of being able to go through all of their material, scan through it, and try and figure out if there was a way that could try and apply this in a machine learning context. I'm glad that we've had the other discussions earlier today because, quite frankly, they've gone over what I've done. My implementation is pretty standard. It's supervised machine learning. It's transfer learning. So again, it's been previously trained on ImageNet. In my case, we actually do have a comparable data source. Whereas with flat landscapes, you're not quite matching up to the classes that are part of ImageNet. Here, we actually have various objects that are figurines of animals, figurines of humans, as well as everyday objects, pots, various vases, that sort of thing. And thus, I thought that this might be a really good way of applying transfer learning to my own. Nevertheless, I was still trying to get to about 5,000 images, and I'll show in a slide or two exactly how that rolled out. In terms of the model I was using, I've primarily been using ResNet, various flavors. I also tried AlexNet and VGG, but I really had the best results from ResNet. I'm using PyTorch because other people in computer science at the university I'm working with are using PyTorch. So I was able to go and ask for help. Otherwise, I've used a couple of different visualizations. TSNE, as you can see up here, just try and explore the data a little bit. But end of the day, I mostly just use Matplotlib to be able to sort of visualize the work I'm doing. Initially, what I did was split out the data into training, validation, and test sets, and I did that manually. However, as time went on, I found that was time intensive, and so instead I started to use the data loader capability of PyTorch to be able to automatically split out my training and validation sets. Ended up, after a little bit of experimentation, doing a 20-80 split. So 80% of the images would be turned into my training set, 20% would be my validation set. And that worked out pretty well. Otherwise, I'm using Atom as my optimizer. I'm using NLL loss as my loss function, and doing batches of about 32 images per epoch. 10 to the -4 for my learning rate, and that seems to work out pretty well. For the actual classes that I'm training towards, I chose 6, and I split them off into Asiatic and Egyptian. Here we can sort of see the Asiatic ones. I did anthropomorphic human figurines, zoomorphic animal figurines, and then just various types of vessels. And you can kind of see the numbers of images I had associated with those. I'll show you in a little bit how many actual objects there were. But as you can tell, there's only about 3 groups there in the human, 3 groups in the vessel. However, there are a large number of zoomorphic. Those zoomorphics, those are primarily jade carvings, as well as Japanese Nitsuke. With the Egyptian subcategories, you have a little bit more diversity. You have standing, head, torso, seated, a lot of Shakti. Just that's pretty standard if you're working with Egyptian material, but also a lot of scarabs, a lot of Sokar hawks, golf baboons. So those ones, a little less diversity, but still you have a large number of different types of objects within that single class. And not so much with vessels. Vessels, it was pretty much just jars, vases and pots, but also with some canopic jars. So at the end, I had 6 classes: human, animal, and vessel for each of my cultural groups. Each one, I had about 750 to 900 images in total. Objects, about 120 to 150, 171 with the Egyptian figurines. Again, a lot of those were Shaptis. And as I went through the training, did about 1,100 epochs on my various models, which were all the various variations of ResNet, and pretty much all of them would converge to 100% validation within 1,100 epochs. Also with a very nice training loss, validation loss. All these sorts of graphs are kind of what you're looking for if you're trying to do a pretty standard visualization convolutional neural network. But the question then is, how can I try and test these? So even though I've had the validation and training set get to the point where it thinks that it can absolutely tell me anything I put into it is going to be correctly classified, what about when I try to come up with ways of finding a real-world application? First test set that I put together was just display cabinet images. And this is still from the Oriental Museum. So it was taking the photographs of these objects that it had been trained on, and the photos themselves that it had been trained on were from ideal photo lab circumstances. So You had a very flat background. You had uniform lighting. It was just the object itself. You're good. However, the display cabinet images, these were taken with a camera phone, and they had variations of light. They had glass reflections. You had background clutter. You had other objects sort of sitting right next to each other. And you had some blurring and from motion of, well, frankly, me just going there and taking really quick snaps in the museum itself, which I left in because I thought, why not? Let's see how it works. Oh, so, what? Sorry. Okay, sorry, one was out of place. These are the display cabinet case results. As was said, computer scientists, we like precision, we like recall, we like F-score. However, we also really like our convolutional matrices. This is your true label. That is your predicted label. What you want to see is a nice line going along the middle, showing that your true label and your predicted label are converging. What I found with the Oriental Museum display case results was that the best results were from ResNet 50. And that it was, however, having a little bit of difficulty in the zoomorphic classes. So, wanted to continue going on, decided to also try another sort of museum display case test set. In this case, I decided I wanted to, okay, I see what I did here. Sorry about that. What I did was go to other museums that had similar collections. The British Museum had its Ancient Egypt Cultural Gallery, its China and South Asia Cultural Gallery, as well as its Enlightenment Room, and collected additional test sets from there and ran it over the same sort of set. And I do apologize. These seem to be out of order. Continuing on, just to bowl through. I started working with the archaeology group. They wanted to see how this could work with a project that they're currently pursuing, which is HEDAP, the Heritage Documentation and Protection. What they're doing is working with to develop a tablet application that could be deployed in a conflict zone, specifically Libya or Tunisia, to be able to quickly record objects from within their collections to be then used for future heritage protection in case any of those objects are stolen and end up on the illicit market. I went in, I took the HEDAP tablet, I took some objects from out of the Oriental Museum's collection and just rapidly took photographs of them to see how well my trained model worked on objects that were of similar provenance, but which were taken using the camera and recording capabilities of this tablet application. And it worked fairly well. This is all kind of still showing some of the better results. I only was able to find a couple of unphotographed human figurines from Asia, but I still managed to get a decent number of test images, and they were still showing that ResNet 50 was performing well. However, there was kind of a bias towards some of the zoomorphic classes that I'm still trying to understand. So, just to kind of wrap up very quickly, I'm looking to see whether or not this will suit the purpose that the researchers in archaeology I'm working with are intending. I'd say that this is sort of a technology readiness level 3. I've shown some interesting results in the lab. I've been able to do like an initial proof of concept, but it's not yet at the point where it can be deployed out into like a real world context. Some of the technical challenges is that data availability, small data, even with 5,000 images, this is still really pushing the bounds of what can be like gotten out of a sample set of this size. I have a lot of issues trying to figure out how to take what I've written up and make it into like an actual production ready and deployable product. And I am finding that with convolutional neural networks, it's driven more by classification rather than identification. And identification is really, in content-based image retrieval, is really what the folks I'm working with are looking for. However, I do think that there's some potential applications in heritage. I think that this is a good way of being able to automate recognition. If you're starting to run into issues with the illicit trafficking on, say, eBay or other online auction sites, probably rather than having someone going there and manually watching it, you're going to be wanting to develop tools like this to be able to automatically flag down illicit material. It also has some capability within museum content management systems. Other than that, just to give some suggestions, what I found was that the CRISP-DM data model really matched the way that I approached my data. Even though it was put in place and mostly used for business purposes, I did find that it still is a very good data model for if you're trying to get into, if you're new to machine learning and trying to develop your own data set. I would just say that some of the most important things I took away from it was know your data, know what sort of bias there is, what objects are most popular and thus most photographed, what past research has been done. Again, I have a lot of scarabs in my data set just because someone at some point went in and photographed a lot of scarabs. Also, just to always be sure to be continuously visualizing your data to find new ways of exploring it. You're having to deal with just massive quantities of image data, and if you can try and come up with easy ways to help yourself visualize it, explore it, that's going to help you in the long run. Otherwise, just keep on watching changing technology. Hopefully we'll be approaching a few-shot and one-shot learning soon. And just always know that there's trends in open source and computer vision. The fact that we're all here kind of discussing this together kind of shows that there's interest, but that it is still a very rapidly evolving field. And I think that's it for me.